In stoichiometric calculations, you guys are going from the mass of one substance, like a reactant, to the mass of another substance, like a product. Okay. Now, if you look at a full mass to mass calculation, you're going to take three steps. You're going to go from mass of the original substance to moles of that substance, step one. From moles of that substance to moles of the wanted substance, that's step two. And then from moles of that wanted substance to mass, okay? And that would be the third step. And so for two of those steps, step one and step three, you are going from mass to moles or moles to mass, which you should already know how to do by either dividing by the molar mass or multiplying by molar mass. That middle step, step two, is the new one. All right, that's the one where you're going to go from moles of that given to moles of your wanted, and you have to use something new called the mole ratio. Now, um, before we get into doing a calculation with the mole ratio, I just wanted to go over some information. All right, and so the first thing I wanted to look at is a balanced chemical equation. All right, and so in this case, we have silver iodide reacting with iron 3 carbonate, producing iron 3 iodide and silver carbonate. All right, and when we balance that equation, we get the coefficient 6, 1, 2, 3. All right, and that's how we normally look at that. Well, a new way of thinking about that is in terms of moles and saying instead of just six silver iodide molecules, you would say 6 moles of silver iodide reacts with 1 mole of iron 3 chloride. And this is what we get. Not iron 3 chloride, iron 3 carbonate. Sorry about that. And this is what we get. So, this new relationship between the compounds is what we can use to convert from moles of one substance to moles of another substance. So if I know that the relationship is 6 moles of silver iodide are needed for every 1 mole of iron 3 carbonate, I could manipulate that relationship so that I could find, well, what if I have 12 moles of silver um, iodide? How many moles of iron 3 carbonate will I need? Okay, and so it's a doubling of that. But what if I have half of that amount? So if I have half of the silver iodide, I only have 3 moles, then I'm only going to need half of this amount. Okay, and so having that relationship helps me out, and it is what the mole ratio is all about. All right. The mole ratio is a conversion factor. It's a fraction. Okay. It's a fraction and it comes from the coefficients in your balanced equation. So balancing that equation is very important in order to do this correctly. Now, how does the mole ratio look? Well, I said it was a fraction. And so you're going to have what you want over what you're given. And then X and Y are your coefficients. All right, so like anything else, we're going to do some practice problems. I have two practice problems here. I'm going to use that equation that we already balanced. All right, and so the first thing I want to do is read the problem, identify my given and my wanted, and then set the problem up correctly. So in this case, it says how many moles of silver iodide would be required to form 10 moles of silver carbonate. Okay, so how many moles of silver iodide? So moles of silver iodide, that is my wanted. That's what I want to find. Okay, and then 10 moles of silver carbonate, that is my given. Okay, that is what I'm given in the problem to help me get started. All right, so I'm going to go from moles of silver carbonate to moles of silver iodide. So to set this problem up, you always start with your given amount, 10.0 moles of silver carbonate, and you're going to multiply this by your mole ratio. The mole ratio is wanted over given. So I'm going to start here. I'm going to find my wanted, which is moles of, I'm going to go MOL of AGI. And then I'm given AG2 CO3. Okay. The numbers come from the coefficients in your balanced equation. So the coefficient for AGI is 6. The coefficient for, AG2CO3 is 3. So it's going to be 10 times 6 over 3, which is 20 moles of AGI. Okay? Let's look at another example. It says, how many moles of FeI3 would be formed from the reaction of 4 moles of Fe2CO33, iron 3 carbonate with excess silver iodide? Now, excess just means it was left over. It's extra. It has no bearing on the calculation itself, okay? It's like if you were making sandwiches and you had excess bread. It has no bearing on the number of sandwiches that you made. It's just the bread that you have left over. All right? So here we go. We're going to start with what we want to find, moles of iron 3 iodide, and what we're given is moles of iron 3 carbonate. So I always start with my given amount, 4 moles of iron 3 carbonate. Okay, and I'm going to calculate and find moles of iron 3 iodide. So that's my given. That's my wanted. It goes on top. My given goes on the bottom. And one thing I didn't do in the problem above is I did not cross out the units that I do not want anymore. So like this right here, you can see if you have your mole diagram, your mole ratio problem set up correctly, they will cross out. All right, so here I have 4 moles of iron 3 carbonate, and I'm going to convert that to moles of iron 3 oxide. And so all I need to do is my coefficients. So FeI3 has a coefficient of 2. Fe2CO33, no coefficient, is understood to be 1. All right, so I do my calculation. 4 times 2 over 1, which is 8 moles of FeI3. Okay? And that is how you do calculations using the mole ratio.